2025 didn't go as planned.
535 मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P2CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hello students, good afternoon. How are you all? Welcome to one more amazing session from Infinity Learn by Sri Chaitanya Academy. How are you all? Can you all able to see me? Can you hear me? Please give me confirmation in the chat box. So आज हम चर्चा करने वाले हैं history of recognizing the patterns, the periodic table, genesis of the periodic table. How you are all able to see? Okay, today I just want to give you a well equipped animation. आपको मजा आएगा, बहुत मजा आएगा. Okay, before going for the session, I just want to give you a little promotion about Atreya program. So Atreya program is well defined. We want to make you to change from we didn't do to we will do it. So those who are not done well in the NEET 2025, you can take a drop and you can do the best for the next 2026 NEET examination. For that, Sri Chaitanya Academy by Infinity Learn is going to take you Atreya and crack your NEET, introducing this program, India's most powerful NEET preparation program. In this program, you can see P2CB. This is a super awesome problem. Actually, those who are preparing for NEET examination, the nightmare is going to be the physics. As you witnessed NEET examination 2025, physics paper is slapped like anything. So we want to come out of this resolution. So double your preparation for physics. That is revolutionary NEET preparation for P2CB, which includes double focus on physics with chemistry along with biology. So definitely you will be doing good. Enroll now, link is available in the description box. Let me just tell you the program features over here. So the batch commencements, already batch is started in May 2023, May 23, where the further attachment of batches will be there. You will be conducting the batch from 0 day and you will be having a classes from Monday to Saturday. Sunday ka chutti hai, and you can see each session is going to be 90 minutes better and 3 classes per day. Each class is 90 minutes and you have 2 concept classes and 1 practice session. In that you can see there are 18 classes per week. In that you have the double revision program for physics as well. And I just want to tell you one important thing, you will be having an interactive classes by expert faculty. How many? 465 interactive classes, bacho. You will be giving 240 DPPs, and at the end of the session notes will be converted into PDF format and automatically it will be reached to you. And also dedicated practice classes, 120 plus hours are there. In that physics will be given more emphasis. And also, my dear children, here this is a very important 2025 only will be there in a batch where practice session is going on. So that student will be having a kind of interactive and more exposed and customized doubt clarification will be there. And this is very important. And this match you can see here, and promotion is over. Once you already completed your NEET examination, you can go ahead with your prediction of what is the score and what is the expected rank and everything, where you can get a chance in the AIMS or AFMC or you can say GMC or anywhere. Dear students, link is there and you can click it and you can enjoy it as well. Right? So we'll discuss about the concept. In this Nirman program, we are going to discuss the topics and it is purely NEET, and both 11th standard and 12th standard syllabus will be discussed, where you can see those who are preparing for 11th as well as 12th and dropped students also can get the benefit of today's class. And please like the session and share with your friends and subscribe to NEET Infinity Learn channel. Okay, anyways, let's move ahead right from the scratch level, from the periodic classification. Let's talk. And here all about why do we need to classify the elements. Yes, we have to classify the elements. Like modern periodic table, you have topics for the day, modern periodic table, systematic nomenclature, and also history as well. And ready for that, everybody? So we made this periodic classification animation so that you can just see, and realistic pictures also. I just want to say hi Geeta Madhuri, how are you? Hello, how are you doing? And yeah, we are ready. Okay, now let's talk about why do we need to classify the elements. That is the question. We have to start with a question. So just to organize, if only 3-4 elements are known to us, you can just memorize it. But if it is there, huge number, 118 elements are there. How do you memorize their patterns? Let's think a scenario where all the 118 elements are gathered together. How weird it would be. 1, 2, 3, 4, 5, 6, like this, 118 elements. So there should be an organization. And you can just put it in the blocks directly, 118 blocks, just like a building. Then how to recall this? The problem comes with recalling the things. So how do you find a book in your interest from a library? If you say a bunch of books are there in Almara, how do you get it? How difficult it would be, all books were mixed up. Now we can see here, to organize, yes, spoons arranged in a kitchen trolley. If it is organized, you can pick it up. Books organized in a shelf. Dear children, you can see this is a shelf. It is organized, not organized. I don't know. I want to get a book. Pick the book. If it is there, 10 books, 20 books, 100 books. How to pick it and how it is. But it is simple when you go into the library. How the library is organized here, you can see. Even in the trolley, it is spoons, cutleries and everything, forks. You can just take a fork because in the dump you can't put it, right? If you see in the library, you have the English books, you have my favorite chemistry books over here, and you have the physics books over here, and biology books over here. If I ask you to go and get a chemistry book, you can directly go and pick your chemistry book. You can't just take from the dump, isn't it or not? Yes. Now to organize the elements, we need this classification, and for this classification of elements is started. So 118 elements are there so far. How to get this classification in 118? You need a systematic, scientific algorithm based classification is required. And to ease the problem of studying the elements separately, the chemists searched for a systematic way to organize their knowledge by classifying the elements. Stay tuned. I am going to show you the awesome pictures and awesome animations so that you can really enjoy it. And let us talk about the first stories. Why the name periodic classification? First of all, we say all elements are classified in a table. So generous question, do we have to memorize the table? Of course no. Really, you had it clearly. No need to memorize this, right? Rather, you just memorize, just know the algorithm behind the periodic classification. Are you getting or not? So, periodicity means a repetition of a property in a regular interval. Okay? Sorry. So, why the name periodic classification? There you can see, it answers everything here, right? So, now here the term periodic is used to indicate the properties of the elements repeats themselves in a regular interval. And let us see how it is repeating and what is the reason behind the repetition. And that is given in the history, developments of the periodic classification. It's right from 150 years ago it started. And it is going on. First law of triad is given, and the Newlands octaves are given. Then Mendeleev periodic table is given, and modern periodic table is given. And this is the hierarchy where you can see. Meanwhile, here you can see Lothar-Meyer atomic volume curves as well. And of course, this is the chronological order, law of triads, Newlands of octaves, and Mendeleev, and modern periodic table. Shall we start here, Geeta Madhuri? Are keep interacting with the guys, right? Anisha is there in today's class? Abhinav? Okay, the previous class Altamash came and he was doing like anything. So don't fear about the result. Okay, dear students, you did your best. Okay, and just expect the fruit, and if it is good and enjoy it, if it is not, just repeat it. My dear students, here Infinity Learn YouTube channel will be always there with you to support you. Okay, so let's focus here. Newlands law of triads, Dobereiner law of triads, Newlands octaves, and Lothar-Meyer atomic volume curves, and Mendeleev periodic table, and many things we are going to discuss in today's class here. So Dobereiner law of triads, it is in the 1829, almost 200 years ago, right? So what he did? So a group of 3 elements possessing the similar characteristics are there. So you want to say a group of 3 elements, A and B and C. So he want to say atomic weight of the middle element is the average of the atomic weight of the arithmetic mean of the A and C. Atomic weight B is equal to atomic weight A and atomic weight C by 2. So this is matching, and this is said to be a triad. So group of 3 elements possessing similar characteristics are made. And the atomic mass of the central element was merely the arithmetic mean of the masses of the other 2 elements. So let me give you the example with super animated example. You can see here is the one, he is the one, John Dobereiner. He is the one, John Dobereiner. Okay. So let's see what he did it. Ready? My dear children, I want you to be more interactive, so that this is not a radio session or recorded session. This is a live interactive session from Infinity Learn YouTube channel in the studio, and you can have interaction with me, and you can ask doubt, and take a pen and paper and talk to me, and let's make this session super awesome, right? Let's talk about John Dobereiner, what he did it. He has taken the elements lithium, potassium and sodium, calcium, barium and strontium, chlorine, iodine and bromine. Sir, here sodium is not written, here strontium is not written, here bromine is not written. So how do we get this? Now my dear students, if you take the atomic mass of the lithium, atomic mass of potassium, and take the average, and you are going to get a sodium here, you can see the atomic weight of these 7 plus 39 by 2 is equal to 23 is the sodium. Similarly, 40 plus 137 by 2 is equal to 88, it is strontium. 35.5 plus 127 by 2 is equal to 80. Are you getting or not? Like this, how the animation is come. So this is a better learning platform, my dear student. Love it? You want me to play it again? Yes. Now you can see how these elements triad is seen. Sodium, lithium, sodium, potassium are the 3 element is called triad, where the average of lithium and potassium is going to be sodium. Average of calcium and barium is said to be strontium. Average of chlorine and iodine is going to be bromine. So now I just want to post this in the animated form, and everybody can see and enjoy. 7 plus 39 is going to be 23, that is a sodium. Yes, it is. and 40 plus 137, average is going to be 88, it is strontium. Similarly, 35.5 plus 127 by 2 is equal to 80. Now you like it? Clear, my dear students? Any doubt, you please ask us. And our content team made a lot of effort to do this animation, and we want to do it. Yeah, it is there with Infinity Lens. Sri Chaitanya, please follow our videos and please like this session, share with your friends and subscribe to NEET Infinity Lens channel so that you will understand more concepts like this. Now, what are the actual things, drawbacks of Dobereiner triads? So, this is the first classification, has no scientific impact. But the drawback is that it is only confined to a few groups. Since the Dobereiner relationship, referred to as law of triad, seems to work only for few elements, it was dismissed after as it's a coincidence, that's it. It is not about every element, it is not applicable. So that it is just taken into the history, nobody follows this and we don't have any application of this. But maximum you are going to get a triad के हिसाब से एक क्वेश्चन मिलेगा, ट्रायड के हिसाब से कौन सा ट्रायड होगा, इसका ट्रायड का कॉन्सेप्ट क्या होना चाहिए. Understand? Now, let us talk about law of Dobereiner drawback. Now, Newlands law of octave, just like a music chord. Just like a music chord. Newlands octave is given 1865. And you see how civilization is developed day by day and where we are. And it is a long ago. So, he said arrangement of the elements in increasing order of their atomic weights. And he is noting that the properties of every element is similar to the first element. Now, let us look at this. He is Newlands, John Alexander Newlands. So, has somebody contributed, we need to just talk about him. Okay, my dear students, here we can see Newlands octaves, the elements are arranged in increasing order of the atomic weight. So, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, and you can see this is the first element, second element, third, fourth, fifth, sixth, seventh, eighth element. Okay, I just want to say here the eighth element is going to repeat the properties of the first element. So, sodium repeating the properties of lithium, beryllium and magnesium repeating the properties, and it goes sulfur and oxygen repeating the properties. It is an awesome thing. And the beryllium, magnesium and calcium is repeating the same properties, potassium, sodium, lithium repeating the properties. Of course, its repetition is only confined about calcium. After calcium, his logic is not working. Just like a music chord, sa, re, ga, ma, pa, da, ni. How many of you know music? This is all about music chord. It looks like music chord and it is said to be octave, 8 elements. Okay, so 8th element is going to repeat the properties with the first element. Are you getting or not? Wonderful. So, this is about the law of octaves, and this law of octaves again it is discarded and it is in 1865. You can say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Okay, and after that sodium. So, first element, second element, element status you can see first, second, third, fourth, fifth, sixth, seventh, and this is the 8th element. Now, the students has some kind of doubts. Where is hydrogen? Where is hydrogen? Hydrogen has no place in any form of the periodic table, my dear students, any form of the periodic table. And also you can see, where is helium, neon, argon? Array, it was in 1865. It was 1865. Noble gases are not discovered at that time, my dear children. Fine. So, first elements, second, third, fourth, fifth, sixth, seventh, and 8th element is a sodium repeating with the first element. This is called law of octave. And first, second, third, fourth, fifth, sixth, seventh, and 8th element is repeating with the first element. You understand? And it is only confined to up to calcium. That's the reason why it is not followed at all. But this is the first observation of the periodicity of the elements, my dear children. And you can see here periodicity, drawbacks of the Newlands octave. Drawbacks of the Newlands octave. Yeah, Eid Mubarak, beta. Eid Mubarak, thank you very much. And drawbacks of Newlands octave. When you see the drawbacks, arrangement of the elements up to calcium was possible. By that time 56 elements were known, but this logic doesn't working after calcium. And also this is discarded. Now Dmitry Ivanovich Mendeleev is given his periodic table in 1869 from Russia, and he has taken arranged 63 known elements in increasing order of atomic weight. Bacho, he is based on atomic weights. So at elements with similar chemical properties and physical properties occupy the same column. This is the first tabular form of the periodic table, Mendeleev periodic table. Okay, and according to Mendeleev, who is Mendeleev is coming there, Dmitry Ivanovich Mendeleev. I like him very much. 200 years ago, almost more than 150 years ago, Russian scientist, he made his periodic table. Still we are following this Mendeleev periodic table modified by Moseley, and Moseley periodic table is metamorphized into the Mendeleev modern periodic table. So the periodic table that is printed in the textbook is basis of the Mendeleev periodic table. How powerful it is, always, okay. And you see, according to Mendeleev, the properties of the elements are the periodic functions of their atomic weights. Got it? अरे बच्चों, अगर कुछ doubt है ना तो पूछना. So he arranged the elements like this. So when you see his periodic table, what is special about Mendeleev periodic table? अगर कुछ आपको पता है ना तो हमको पता कर लीजिए. And you can see he ignored the order of atomic weights and placed the elements with similar properties together. First he ignored the atomic weight, and first he arranged the elements according to the similar properties. Okay, and he adjusted the atomic weights of the elements assuming that they were not measured accurately. So he has taken valency into the consideration, and atomic weight is equal to equivalent weight into the valency, and he corrected the atomic weight of some elements as well, like beryllium, and he predicted the properties of some undiscovered elements and left several gaps. By that time some elements were not known, but he predicted the properties of those elements. And two of them are under aluminum and silicon are called eka aluminum and eka silicon. Later they are germanium and gallium. They are predicted, and their properties are also look same. So actually he left some gaps in his periodic table. That itself is a defect in his periodic table, and defect drawback in his periodic table, and this periodic table is coming to be the advantage of this. Are you getting or not? Right. Now let's talk about, this is the periodic table, Mendeleev periodic table. You can say in his Mendeleev periodic table, you can say vertical columns are called groups and horizontal rows are called periods. He has 7 periods, and 7th period is not seen there, and 8 vertical columns. 7 periods and 8 groups are there. Later 0 group is being added, and each group is given A subgroup and B subgroup. You have to identify, and A subgroup and B subgroup. And whereas here group A is given as A as well as B as well as C. So that comes in the transition series. This is a transition triad. Okay. So this you have to study what exactly is happening. When you see lithium, sodium, potassium, rubidium, cesium, all have the similar properties. Copper and silver has the similar properties. But the thing is, you see beryllium, magnesium, calcium, strontium and barium having a similar properties. Observe the pattern actually. Okay, but some abnormalities are there. You take gold, you take a platinum, they have the nearly similar property. Okay, so he cannot place these elements in the same group, and you can see abnormal values. 55.85 is there, 58.93 is there, 58.71 is there. So the lower value is given the next. So this is an anomalous pair. Similarly, iodine and tellurium is given. 127.6 is greater value, 126.9 is a smaller value. So there is an abnormality. So there are certain things he has some problems, and he cannot place hydrogen even, and he cannot place the isotopes even, but it is based on the atomic weights. Let's talk about drawbacks of Mendeleev periodic table. So hydrogen did not have a fixed position. It is kept like that for the namesake. And also, there were no regular trend in increasing order of atomic mass while moving along the elements. But also isotopes were not found later, in which it failed to completely fill this periodic table. Are you getting or not? So these are the various defects. Later on Moseley came. What Moseley said? Students, अगर कुछ डाउट है ना तो पूछना बेटा जल्दी. गीता मौदरी. Right, moving ahead. So Moseley modification in 1913. You see the history going along with the numbers as well. Okay, so now Moseley, Henry Moseley, I love him. He is one of the great scientists in the physics, and he contributed so many things in chemistry as well, and he discovered atomic number, and he said atomic number is the fundamental property of an element. Okay, Henry Moseley, he conducted experiments by using his X-ray discharge tube. This X-ray discharge tube is designed by Roentgen, and he discovered X-rays, and he want to do X-ray crystallography experiments. While he is doing X-ray crystallography experiments, he found that root nu is equal to A into Z minus B. So nu is the characteristic of X-rays, frequency of X-rays, and Z is atomic number of these elements, while A and B said to be mathematical constants. So by observing this, he filled this tube with hydrogen, he got the X-rays, he observed the frequency of the X-rays, and he solved G value over there. And Henry Moseley did helium, neon, and nitrogen, oxygen, carbon, many elements, and he found the atomic number. Now he modified his Mendeleev periodic table with the elements according to atomic number, and he said that Moseley periodic table. Yes, basic concepts of chemistry के one short video upload कर दो class 11 में. Definitely, if you want, already based on this live session is completed beta. You are requesting me or demanding me, I don't know, but it is already done. You can see the channel, you are going to find that video. Okay, my dear students, let us see here. And he made his periodic table, that is Moseley periodic table. When you talk about the Mendeleev periodic table, the periodic table looks little clumsy. A category, B category are there. He want to separate the A category and the B category. It is found, it is lengthy. So it is called as long form of periodic table. Understand? It is called as a long form of periodic table. Later, the long form of periodic table is correlated with electronic configuration. So, that is called as a modern periodic table. Okay, we can pin it. Okay, no problem, better. Just at the end of the session, you just write the comment box. I can put that video, right? I can put that video link as well. Don't worry, beta. And you can see here the modern periodic law and modern periodic table. And you can say that physical and chemical properties of the elements are the periodic functions of their atomic numbers. And the periodic law is essentially for the consequence of the periodic variation of electronic configuration, which determine the physical and chemical properties of the elements of their compounds. And that is called modern periodic law, and this is going to be modern periodic table. How the elements are arranged in the modern periodic table? They are arranged in increasing order of the atomic number. Increasing order of the atomic number. So, this is how it is visible. This is how the horizontal rows, I just want to show you here. I just want to show you how it is designed according to the electronic configuration, right? Now, look at this. So many things are there. Get ready and I will show you. Some questions are also there. Right. Now, students, let us see how this electronic configuration can help you to identify the periodic table, how it is designed. Carefully see here. First, according to the electronic configuration, first 1s orbital is filled. You don't have 1p orbital. Then 2s orbital is filled. You have 2p orbital. You have 3s orbital is filled. You have 3p orbital. Carefully see. And 4s orbital is filled. You have 4p orbital. And 5s orbital is filled. 4s and 4p. And after that, you need to know about the 3d orbital. 5s orbital and 4d orbital and 5p orbital. And 6s and 5d and 6p. So, these are the orbitals. And before that, you are going to see 4f orbital bacho, 7s orbital, 5 and 6d, and you have 7p orbital. So, can you believe it? This is the pattern of the periodic table. I just want to show you that also. Look at this. Here, this is where s orbital filling elements are there. This is where p orbital filling elements are there. Okay, this is your periodic table. This is your periodic table. Got it? And this 1s is going to have s orbital can have 2 electrons, and p orbital can have 6 electrons. 1, 2, 3, 4, 5 and 6. And you know, d orbitals can have like this, and d orbitals can have how many beta? You can see here 10 electrons. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, you can see how many vertical columns are seen? 18 vertical columns are seen. You can see, let me count it. 1 here, 2 here, 3 here, 4 here, 5 here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 groups are there. Dear children, I want to show you by animation also. Let me give you the manually first. And you can see These are the periods, bachcho. These are the periods. These are the periods. And I can say this is the first shell is being filled, second shell is being filled, third shell is going to be filled, fourth shell is filled, fifth shell is filled, and sixth shell is filled, and seventh shell is filled. Okay, so there are 7 periods and 18 groups. And if you start giving the numbers of this, you're going to get atomic number 1 and you're going to get atomic number 118. There are 118 elements are present in the periodic table. This is very important. And also, my dear students, here you can see 4F and 5F you cannot accommodate, so that 4F and 5F outhouse में दिया. So they are calanthanides and actinides. Will be discussing it soon. Understood? Any doubt as far as this question is, as far as this table is concerned? Now let me just show you the technical version of this. Right? This is how the periodic table has been designed. You need to know the design. Rather, you just guys ask about how we memorize this, but we need to know the design of the periodic table. And this periodic table gives the total command on your inorganic chemistry. These periodic properties are based on this design only, my dear children. Okay, let's see here. The design is over, and let's see designated one. And I have some tricks to identify the groups and periods. You got it? The long form of periodic table. Get ready. Now beautiful pictures will come. Long form of periodic table, elements are arranged according to the atomic number and electronic configuration. It's called long form of periodic table, where you can see the modern periodic table. This is your modern periodic table. And let us see, these are the elements. You can see hydrogen here. And these are alkali metals and alkali earth metals. You can see the color code also. Okay, metalloids you can see, non-metals you can see, noble gases you can see, F block elements you can see, D block elements you can see. Now let us go into the details of this. When you go into the details, modern periodic table details, let's see in terms of groups and periods, bachcho. In terms of groups and periods, you have 18 groups and 17 periods. Vertical columns are called groups. Horizontal rows are called periods, bachcho. Okay? And this is how you can see the alkali earth transition, boron family, carbon family, nitrogen family, oxygen family, halogens and noble gases and the F block elements. You can see here again alkali metals, alkali earth metals, transition elements, boron family, carbon family, nitrogen family, oxygen family, halogens and noble gases. Are you getting or not? Fine, you like this animation, right? One should get the attracted. Okay. So here you can see this is periods. You can see here, my dear children. This is group 1, group 2, group 3 to 12, 13, 14, 15, 16th group, 17th group, 18th group. Now you can see group 1, NS1 configuration, group 2, NS2 configuration, group 3 to 12, NS1 to D1 to 10, NS0 to 2, and here P1 configuration, P2 configuration, P3, P4, P5 and P6 configuration. So this is how the electron configuration is seen in a given group. Understand? Right. So you like this animation? Geeta Madhuri there? Okay. Now let's see periods. It is the first period, second period, third period, fourth period, fifth period, sixth period and seventh period. And when this light is coming, you can see, when you can see these are the elements, F block elements actually belong to this. Yes, that's the reason why it is shown here. That's the reason why it is shown here. Because of the place is not sufficient, it is kept in the different, it is kept in the outside the periodic table, right? Now let's see the group wise blocks in the periodic table. Blocks in the periodic table. So you have, we can classify the element into 4 blocks depending upon the differentiating electron entering into the orbital. Okay, if the electron enters, what is the differentiating electron? The electron by which an element differs from its previous element is called a differentiating electron. Based on differentiating electron, the elements in the periodic classification is classified into S, P, DF blocks. S block elements, electron, differentiating electron enter into the S orbital. P block elements, the differentiating electron enter the P orbital. D block elements, the differentiating electron enters into the D orbital of the penultimate shell. And F block elements are the element differentiating electron enter the F orbital of anti-penultimate shell. So these are the things you need to know. So depending upon the type of subshell that are being filled with the least, at least the last electron here, you can see S block elements, P block elements, S block, P block, D block and F block. Let's see here, it is named here and shown here. Are you getting or not? अगर कुछ डाउट है ना तो पूछना बेटा. You like this colorful periodic table? Okay, moving ahead, here you can see the various types of elements. These are the S block elements. And you have the P block elements even. And D block elements, you can see this is the S block elements, the elements in which S orbital is filled. They include alkali metal and alkali earth metal. Okay, these are the S block elements, right? Alkali metals includes, don't say hydrogen, okay, just for namesake it is kept like that. And lithium, sodium, potassium, rubidium. Lithium, sodium, potassium, rubidium and cesium comes under this alkali metal. Sir, we didn't pronounce it francium. Francium is a radioactive element. It is known very less. Knowledge is known for the francium. Just for the sake of electron configuration, यहाँ पर रख दिया. इसका बारे में कितना पूछा नहीं. And beryllium, magnesium, calcium, strontium, barium, radium comes under alkali earth metal. Let's talk about the next one is a P block elements. So S block elements in detail में देखना है. In the S block which contain hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. And hydrogen is placed here for the sake of name only, but actually hydrogen has no place in any format of the periodic table, bachcho. And they are said to be alkali metals. They all have the general electronic configuration of NS1. Okay, and let us see the alkali earth metals as well. And they are second group in the S block. You can say it is beryllium, magnesium, calcium, strontium, barium and radium. They are said to be alkaline earth metals, but beryllium is not considered to be alkaline earth metals. Why beryllium is not considered to be alkaline earth metal? Somebody mention in the chat box. I want to wait for your answer. Beryllium forms an oxide which is amphoteric in nature. That is the reason why it is not regarded as an alkali metal. Okay, and talking about the P block elements, again periodic table. Come on, which includes group 13. This is also called as a boron family, and boron, aluminum, gallium, indium, thallium comes under, and these are called icosagens and are also called as a boron family. They are also called as trial elements. They have NS2 NP1 configuration. They have NS2 NP1 configuration. Okay. And talking about carbon family, group 14 is also called as a carbon family, and which includes carbon, silicon, germanium, tin, lead and Fl. And we talk about lead only. These are all artificial elements. Okay. And you can see here, this is also called as a crystallogens. It has a NS2 NP2 configuration. They are also called as carbon family. They are also called as a carbon family. Okay. बच्चों अगर डाउट है ना तो पूछना बेटा जल्दी. Right. Enjoying these animations, huh? Very good. Now let us talk about group 15. So group 15 and the P block elements, this is group 15 nitrogen family. In this nitrogen family, nitrogen, phosphorus, arsenic, antimony, bismuth. They are also called as nictogens, are called nitrogen family. And it is going to be NS2 NP3 electronic configuration. It is going to be NS2 NP3 electronic configuration. You can see P3 off-filled electronic configuration, that makes it chemically distinct with the other elements. Off-filled electronic configuration gives an extra stability. That is the nitrogen almost behave like an inert gas because of high bond energy between nitrogen to nitrogen, 946 kilojoules per mole. And also his off-filled electronic configuration. Nitrogen is not at all reactive at all. You require a lot of energy. And let's talk about the group 16 elements. In this group 16 elements, you have oxygen, sulfur, selenium, tellurium and polonium. They are also called as a chalcogens. Chalco means mineral. These are going to form mineral. They have the mineral forming tendency, so that they are said to be chalcogens. And is also called as oxygen family. They are also said to be oxygen family. Okay. And you know, polonium, the name polonium is given, this element is discovered by Madame Curie. She belongs to nation Poland, and on the honor of nation Poland, polonium name is given. Okay. And let us talk about the noble gases there. After this, halogen should come. So let's talk about halogens here. P block elements as halogens: fluorine, chlorine, bromine, iodine and astatine. And they are also called as halogens. They have NS2, NP5, and these elements are also called halogens. Why? Halo means salt. They have the salt forming abilities. That's the reason why they are said to be halogens. And noble gases are there. In the P block, you have the noble gases. Helium is an exceptionally placed here because of its behavior. Noble gases: helium, neon, argon, krypton, xenon and radon. And they are called as noble gases, or also said to be inert gases, or M8 elements. Other name, They are also called as the rare gases. And these are all noble gases. Let us see the d block elements here. Completely fluid orbitals are there. They are never and ever react with anything, but xenon is appeared to have a little reactivity with oxygen and fluorine and forms a few compounds in extreme conditions. Why xenon is going to form compounds with oxygen and fluorine? Because xenon का ionization energy and oxygen का ionization energy ये दोनों का बराबर, मॉलिकुलर ऑक्सीजन का आयनाइजेशन एनर्जी दोनों बराबर होता है. So XePtF6 okay is a compound is seen. Okay, we'll discuss in the noble gases and the p block elements regarding that. Okay, my dear children, here you can see these elements that are shown, total S block elements and total P block elements except noble gases are said to be representative elements because their elements represent their electronic configuration. Okay, and I just want to show you something here. D block elements, the D block elements. So these elements are called D block elements. They are also called as the transition elements. Transition elements and D block elements are same, but the D block elements is completely D block elements. Transition elements are the elements in which the incompletely filled d orbitals are seen either in the ground state or in stable oxidation state or stable ionic state. That is the reason why zinc, cadmium, mercury cannot be regarded as a transition elements. Rather, these elements are going to be transition elements. Let's talk about these special characteristics of these D block elements here. The D block elements, the elements are shown. So here first 3D orbitals are gradually filled, so these are called 3D series. Hi Bachi. Okay, here 4D orbitals are being gradually filled, so they are said to be 4D series. 5D orbitals are being gradually filled, that is called 5D series. 6D orbitals are filled, this is said to be 6D series. Okay, and 3D series scandium to zinc, and 4D series a terbium to cadmium, and 5D series lanthanum आएगा यहाँ पर, lanthanum to mercury, and here it is going to be actinium to copernicium Cn, and these are called transition elements except zinc, cadmium, mercury and Cn. And let us see here, all are metals, all can form, a few can form colored ions if you write the electronic configuration among them, and if you have unpaired electrons in the any ionic electronic state, it is going to be colored, otherwise it is colorless. And also they have the general electronic configuration n-1 d 1 to 10 and ns 0 to 2. Why 0? Why 0? Palladium has 5s0 configuration, इसका हिसाब से ns 0 to 2 दिया हुआ. And also you have variable oxidation state. Iron can show +2 and +3 oxidation state, like that. And also you can say these are transition elements, and some of these compounds act as a catalyst, and some of them compounds or ions can be paramagnetic, and these are the various properties of the D block elements. If you have any doubts, my dear children, please feel free to ask. Feel free to ask. Right, now moving ahead, why are D block elements are called transition elements? Now quickly give the answer, quickly give the answer. If anybody knows, quickly give the answer. Dear children, Why D block elements are called transition elements? Why D block elements are called transition elements? Again the same question. Simple. So, I wanted to say D block elements form a bridge between the chemically active elements of S block and the less active elements of the group 13 and then 14. They are hence called transition elements. Okay. And these are called, you see, exceptions in D block elements. That's very important, bacho. In this exception, zinc, cadmium, mercury have electronic configuration completely filled electronic state. Because of this completely filled electronic state, they are not transition elements since they have completely filled shell. Even in the ground state, even in the ionic state. Unlike you say copper is completely filled D10 configuration. But in the copper 2 plus, you have D9 configuration. So, that copper can be considered as a transition elements. And here talking about the F block elements. These F block elements, they start from cerium. So, lanthanum belongs here only. After lanthanum, they comes as lanthanide series. After actinium, they comes as actinide series. Actually, lanthanides and actinides related to these D block elements, my dear students. So, these F block elements, the differentiating electron enter into the F orbital. They starts from 4F series is filled here. So, that is called inner transition, first inner transition, and 5F orbitals are filled here, second inner transition. When 4F orbitals are filled, it is from cerium to lutetium is lanthanide series. Yeah. Thorium to lawrencium is actinide series. Video lectures of basic concepts of chemistry, now I have to study. I tried a lot to get it. Definitely, you just mention in the chart. Okay. Once the session is completed, in the comment box you can write it so that I can tag those videos. Understand better? You don't have to worry about that. Clear? No worries, na? You like this current session? You like this current session? Hi, Rakesh. So, every message and every student will be addressed and pinned and pitched in this live session. So, I would encourage my students to follow our lectures. To take this kind of lectures, to take this kind of lectures, you have to spend a lot of money and you have to travel, and these videos actually we are giving for free. Just please like the session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. That's it. We don't get we don't want anything from you except just like button. That's it. Now let's talk about this F block elements. They include, we are enjoying your lecture. Thank you very much. God bless you. Okay. So, it is starting from lanthanum and to lutetium is called lanthanides, and actually it has to be from cerium 58 to lutetium 108. Yeah. So, Infinite Learn NEET कर yeah, mention कर दो. Yeah, Infinity Learn NEET YouTube channel बेटा. It is there in the description box. You just एक बेल बटन दबाओ, जो भी सेशंस है आपका इंफॉर्मेशन मिलेगा. ठीक है बेटा. Now they are called, they have the electronic configuration n-2 f1 to 14 and n-1 0, either 1 or 0, and ns2. They are called, they are all metals. They are all metals. Okay. And you can see they are F block elements here, actinium to lawrencium. So, thorium to lawrencium comes here, and you know after uranium up to here only the natural abundance, and after all the elements are not naturally found, they are found in the radioactivity. They are found in the radioactivity. Okay, Rakesh, कुछ बोलना चाहता हो तो बोलो बेटा, कोई दिक्कत नहीं. And you know uranium, and it is a plutonium, and beryllium, californium, fermium, mendeleevium, and these are all named after the scientist of their discovery. है ना? Okay, so this is about the classification of the elements, and they have the general electronic configuration n-2, F1 to 14, n-1, D0, 1 to 1, ns2. Here n is equal to 7 over here. Okay, dear children, and we discussed today about how the elements has been classified, and in the next session we are going to see how to predict the position of the elements in the periodic table according to the electronic configuration, according to whatsoever number, and it is also given from the magic numbers. And also eventually we will start with the periodic properties, and after that we will discuss about exceptions in periodic properties. Like that we have so many classes, and follow us, and your NEET journey will be with us, and this is a NEET Nirman program. And finally, I request you, please like the session, share with your friends, and subscribe to Infinity NEET channel. And signing off here, we are done from here, and we are done for today, and signing off, Suresh, Faculty of Chemistry from Infinity Land. Thank you very much.